Hi everyone, welcome back to our channel. In our earlier videos, we have briefly touched on the two groups leading the OpenRAN movement. Here, we will look at them in closer detail, as well as other initiatives around OpenRAN. We'll start with Telecom Infra Project, popularly known as TIP. TIP was formed by Facebook in 2016 as an engineering-focused, collaborative methodology for building and deploying global telecom network infrastructure, with the goal of enabling global access for all. TIP is jointly steered by its group of founding tech and telecom companies, which forms its board of directors, and is currently chaired by Vodafone's head of network strategy and architecture, Iago Tenorio. Member companies host technology incubator labs and accelerators, and TIP hosts an annual infrastructure conference known as TIP Summit. With over 500 participating member organizations, including operators, vendors, developers, integrators, startups, and other entities that participate in various TIP project groups, TIP adopts transparency of process and a collaboration in the development of new technologies. Here you can see a list of currently active TIP projects. All projects are member-driven and employ current case studies to evolve telecom equipment and software into more flexible, agile, and interoperable forms. This picture nicely summarizes the different TIP groups from access to transport to core and services. As a company, Parallel Wireless is focused on OpenRAN and OpenRAN 5G and R groups, as you have heard in our previous videos. The OpenRAN Project Group is an initiative to define and build 2G, 3G, and 4G RAN solutions based on general-purpose, vendor-neutral hardware and software-defined technology. The OpenRAN 5G and R Project Group, as the name suggests, focuses on 5G and R or new radio. You may be wondering, why are we so focused on OpenRAN? As you can see, the general consensus is that RAN is 60% of CapEx and OpEx. Reducing the RAN cost will significantly help the service providers cut their CapEx. The second group leading the OpenRAN movement is the ORAN Alliance, which was founded in February 2018 with the intention of promoting open and intelligent RAN. It was formed by a merger of two different organizations, namely the CRAN Alliance and the XRAN Forum. The CRAN Alliance consisted of China Mobile and a lot of other Chinese vendors. On the other hand, the XRAN Forum consisted of US, European, Japanese, and South Korean vendors and operators. AT&T, China Mobile, Deutsche Telekom, NTT Docomo, and Orange were the initial founding operators. Since then, many more operators, vendors, integrators, etc. have joined. Due to an increase in the amount of traffic resulting from better devices, newer applications, faster connections, and even generous data plans, a complete paradigm shift is required for mobile networks. While 3GPP does an excellent job of defining these new flexible standards, separating the user and control planes, and keeping the different implementation options open, organizations like the ORAN Alliance have an important role in bringing the industry together to create a more software-based, virtualized, flexible, intelligent, and energy-efficient network. These goals can be achieved by evolving RAN to a higher level of openness and intelligence, and the ORAN Alliance does just that. They specify reference designs consisting of virtualized network elements using open and standardized interfaces, and they call for more intelligence in the network through information collection for these virtualized network elements. Artificial intelligence and machine learning can then be applied on this collected information. The ORAN Alliance lays out their vision on their website. As discussed earlier, there are two high-level goals. The first is openness, which will help bring service agility and cloud-scale economics to enable smaller vendors and operators to introduce their own services or customize the network to suit their own unique needs. As we have discussed in our earlier videos, open interfaces enable multi-vendor deployments, enabling a more competitive and vibrant supplier ecosystem. Finally, open-source software and hardware reference designs enable faster and more democratic and permissionless innovation. The second goal is to automate these increasingly complex networks, thereby simplifying operation and maintenance, which in turn will reduce OpEx. This will be possible by embedding intelligence using emerging deep learning techniques in every layer at both component and network levels of the RAN architecture. In combination with the standardized southbound interfaces, AI-optimized closed-loop automation is achievable and is expected to enable a new era for network operations. As in the case of TIP groups, the ORAN Alliance have their own set of working groups, as can be seen here. These 9 working groups can be broadly defined as follows. Work Group 1 focuses on studying use cases and overall architecture. Work Groups 2 and 3 focus on optimization and automation of the RAN radio resource management, or RRM, using the RAN Intelligent Controller, or RIC. Work groups 4 and 5 focus on open interfaces for achieving interoperability between different RAN hardware and software vendors. You will recall from our last video how closed interfaces prevented operators from deploying multi-vendor networks. Work groups 6, 7, and 8 focus on commoditization, virtualization, and modularization of RAN hardware and software. Finally, Work Group 9 focuses on the new open transport network based on new architectures and end-user service requirements for front-haul, mid-haul, and backhaul, collectively known as X-haul. The ORAN software community is a collaboration between the ORAN Alliance and Linux Foundation with a mission to support the creation of open-source software for the RAN. The goal of the ORAN software community is to advance opening the radio access network with focus on the open interfaces, followed by implementation that leverage new capabilities enabled by the ORAN specifications. Back in December, the ORAN software community released its first software code called Amber. It covered initial functionality of the ORAN unique near real-time RAN intelligent controller, the O1 interface, and the protocol stack. Some people may be confused as to why we need different OpenRAN groups and the difference between them. Here we explain the difference between the two leading OpenRAN organizations. Let's start with the ORAN Alliance. The ORAN Alliance develops, drives, and enforces standards to ensure that equipment from multiple vendors interoperates with each other. It creates standards where none are available, for example, the front-haul specifications. In addition, it creates profiles for interoperability testing where standards are available, for example, the X2 interface. Of course, there are a lot more things the ORAN Alliance does, as we briefly discussed earlier in the video. The other major OpenRAN focus group, as we saw, is TIP, or Telecom Infra Project. TIP is more deployment and execution focused. They encourage plugfests and live deployments in the field. TIP enables the OpenRAN ecosystem, ensures different vendors' software and hardware equipment works with each other, is responsible for productization of use cases, and facilitates trials, field testing, and deployment. It should be pointed out here that while the ORAN Alliance is heavily focused on 5G and 4G, TIP is looking at solutions across all Gs, that is 2G, 3G, 4G, and 5G. It would also be reasonable to say that the OpenRAN movement owes its popularity and success to the initial steps that TIP took by bringing together a community of service providers, software and hardware vendors, system integrators, and other connectivity stakeholders to facilitate real-world trials and deployments in different operators' networks. Earlier this year, these two groups announced a liaison agreement to ensure their alignment in developing interoperable OpenRAN solutions. Because TIP is agnostic about the specifications it uses to create the solutions service providers are looking for, it has to work with various standards bodies to ensure smooth operations. But the liaison agreement between ORAN Alliance allows for the sharing of information, referencing specifications, and conducting joint testing and integration efforts. So, if you look at the TIP OpenRAN 5GNR base station platform requirements document, you see normative references to the ORAN Alliance specifications. Within TIP, only companies that are members of both the TIP and ORAN Alliance can see in any discussions related to ORAN specifications. Recently, the ORAN Alliance and GSMA announced they have joined forces to accelerate the adoption of OpenRAN products and solutions that take advantage of new open virtualized architectures, software, and hardware. As you may be aware, the GSMA produces the very well-known Mobile World Congress, or MWC. The GSMA represents the interests of mobile operators worldwide, uniting more than 750 operators with almost 400 companies in the broader mobile ecosystem, including handset and device makers, software companies, equipment providers, and internet companies, as well as organizations in adjacent industry sectors. The ORAN Alliance and GSMA press release stated that the organizations will work together to harmonize in the open networking ecosystem and agree on an industry roadmap for network solutions, thereby making access networks as open and flexible as possible for new market entrants. The Small Cell Forum, or SCF, has created its own ecosystem of OpenRAN with small cells in mind. Recently, they have been focusing heavily on creating open interfaces. Earlier this year, they expanded the set of specifications they released last year to enable small cells to be constructed piece by piece using components from different vendors in order to easily address the diverse mixture of 5G use cases. As you can see from the picture, These open interfaces are called FAPI or NFAPI, which stands for Network FAPI. FAPI helps equipment vendors mix PHY and MAC software from different suppliers via this open FAPI interface. So FAPI is an internal interface. On the other hand, NFAPI, or more specifically 5G NFAPI as shown, is a network interface and is between a distributed unit and a centralized unit of a split RAN small cell network solution. This will help network architects by allowing them to mix distributed and central units from different vendors. In summary, the SCF in FAPI is enabling the OpenRAN ecosystem in its own way by allowing any small cell CU-DU to connect to any small cell radio unit or SRU. As a final point of discussion, we want to talk about a new OpenRAN group that was announced earlier this year. The OpenRAN Policy Coalition represents a group of companies formed to promote policies that will advance the adoption of open and interoperable solutions in the RAN as a means to create innovation, spur competition, and expand the supply chain for advanced wireless technologies, including 5G. Its main goals are to support global development of open and interoperable wireless technologies, signal government support for open and interoperable solutions, use government procurement to support vendor diversity, fund research and development, remove barriers to 5G deployment, and avoid heavy-handed or prescriptive solutions. With that, we'll conclude today's video. We hope you found this somewhat more detailed video helpful in understanding the various OpenRAN groups and how they are working together to enable a truly open ecosystem for various organizations and governments. Please let us know your thoughts in the comments below or get in touch with us to discuss further. You can find us at parallelwireless.com as well as on LinkedIn, Twitter, and Facebook. Thank you, and see you again soon.